Hello. I decided to create a digital weight scale for my embedded systems project. The schematic for my design looks pretty much similar to what I had for Demo 1, but I added a 7-segment display which you can see at the bottom of the picture to display the weight that is measured by the load cell. In summary, the load cell measures the weight and feeds the signal to an amplifier which converts the output voltage to a value that can be read by the board's ADC. On the right side of the diagram you see a motor circuit. If the weight exceeds the maximum capacity that can be handled by the load cell, a warning message is displayed on the 7-segment display and the vibration motor is activated. To calibrate my load cell, I used known weights, which for me was essentially 500 ml water bottles because real weights are expensive. And the calibration process basically involved me plotting the ADC values against the known weight values, and luckily I found out that the relationship is almost linear except for their discontinuity at very low weights. To test our weighing machine, we used two unknown weights in the form of dumbbells. Alright, so for the first test we have a 1 kg load, which is essentially two 500 ml water bottles. The value that we see is 1134 grams, which is off by 134 grams, but that is expected since the measurement error in the load cell is almost 15% and is higher in the lower values. The second test that we have is a 7-pound dumbbell. The expected value is 3175 grams. What we get is 3160 grams, which is extremely close. The third and the final test that we have is a 10-pound dumbbell. The expected value is 4535 grams. The value that we obtain is 4571 grams. Again, extremely close. We do not use any of the dumbbells to calibrate our load cell. Alright, so our last test is to test the overload message, which is thrown if we put a weight that is greater than 5.2 kilograms, which is essentially, let's say, two 7-pound dumbbells. As you see, the overload message is displayed and the vibration motor is activated.